children? All are ready with the science textbook? The new topic, pressure. Last time we completed non-contact forces, electrostatic force, gravitational force and magnetic force. It was very easy. Now let's take the next topic, that is pressure. Now when there is a force, is there any relation between the pressure and force? So when there is a force, the effect is seen on the object in terms of force, in terms of pressure. So when you force something, you exert pressure, right? Now we talk about pressure many times in our day-to-day life. When you press with the hammer in the wood with the nail, generally, practically what we do? We press with the nail with a sharpened nail. We don't press the head of the nail in the wood or in the wall. Will you get a hole with that? No. The same thing when cutting the vegetables. If you cut the vegetable with a blunt edge, will it be easy for you to cut it? No. You require a sharpened edge of the knife. You have two types of knife. One side is blunt, the other side is sharpened. Now with what edge you cut the vegetable? Naturally you cut the vegetable with sharpened edge. So that's the reason. Why do we do that? When there is a nail and you press it in the hole, when you press it in the hole, this is a nail, and if you press it ulta, suppose like this, you press here and you press here. Here you are pressing, the force goes on the whole surface of the head. This is the head. And the force is applied, is spread on this surface. And the force which you apply here is on the tip of the edge, and so the surface area is a spot, one spot here. So the force applied here on the head is distributed. Here the force is focused on only one point, and so you get a hole here very fast. Here you will not get a hole. Even if you take a wooden stick, sharpen like this wooden stick, and you press it to the paper, you will not get easily the hole. You will get the hole with the sharpened edge. Okay. So here, what is pressure? Pressure is directly proportional to the force applied. If you apply more force, there is more pressure. If you apply less force, there is less pressure. Naturally, if you apply force, you get more force, more pressure. If you apply less, you get less force, you get less pressure. And pressure also depends on surface area. Right children, here I told you the surface area. As the surface area increases, the pressure decreases. As the surface area decreases, the pressure increases. So it is inversely proportional, and when we combine this, we get pressure is equal to pressure varies with force upon area. Applied area. So that's what area on which it acts. So F is directly proportional to pressure. That is why we say that, is there any connection between force and pressure? Yes. As force increase, pressure increase. Force decrease, pressure decrease. As surface area increase, force decrease. Surface area decrease, pressure increase. Alright. Even very good example is given in your textbook also. Have you seen the porter on the railway station? We have seen porter, and they tie a turban when they carry the load. They carry so much load of us. When we give them, we ask them to carry the load, what they do is they put 2-3 bags on their head. Now, how is it possible that we are not able to carry them with us and they are able to take it? So, what they do is they put a turban on their head, and so whatever force they carry on their head is distributed on their head of the cloth. The cloth or the turban, what they are putting it here, the force is spread, and that is why they can carry it easily. Turn the page, next topic. So here I have applied that as force increase, pressure increase. Force decreases, pressure decreases. Surface area increase, pressure decrease. And surface area decrease, pressure increase. It is inversely proportional. Now, do you have any answer to my question? Whether the gas and the liquids also exert pressure? Of course, yes. We have seen in our daily life what we do is we just fill the balloon and then we press it and we get a thud noise. Why? Because the air which was there, we pressed them. When we press them, they want more space and we don't allow them the place, they try to come out, and because they try to come out with pressure, they break the rubber of the balloon, and that is why we get a sound. Okay. So now our next topic is pressure exerted by liquids and gases. A very simple example they have given here of glass tube, about 25 centimeter long. You take a tube, both hands are open. Alright. This is about 25 centimeter long and the diameter is 5 to 7.5 centimeter is the diameter and this is the length. Alright, after taking this, now here close this hand with a rubber. Rubber is like this initially. Now feel it. Water. And you will see that the rubber is stretched like this. The initial position of rubber was this. Initial. And after putting this, the rubber becomes inflated. Rubber is stretched. So what does this show? That the water column, this water column exerts pressure on this rubber. That is why the rubber has stretched. Now if you want to confirm again, let's increase the water level from here. So see, now my water level I have increased up till here, and if you see, then my rubber also increases in the stretching, and this shows that if you increase the water level, the pressure increases, the force increases downward, the pressure increases downward, and due to that the rubber which was up till here only stretching, this rubber is stretching so much. You can see that in your textbook also. See, in your textbook they have shown more stretched rubber, right? So this is an experiment where you are explaining how the water exerts pressure. I hope you can do this at home also. You have understood this, very simple. You have to take two pieces of same length and same diameter. Okay, but if you don't have it, no worries, it's okay. Now let's take another example. Activity 11.9. Okay, activity 11.9 is with one bottle. Take one empty bottle of either water bottles, like we purchase mineral water bottle, we purchase from the shop, and when we use it, after it is empty, we can use that bottle for our experiment. And at down part, can you see that at the down part, what you can do is you can make one hole in it. You can make one hole in it. How to do that? Take one bottle, make a hole here, and on the straw, cut the straw in such a way, make a hole here. How to make a hole? Take a something of metal, heat it and put it inside and you will get a hole. See that it should not leak, and then stick it properly so it is not leaking, and then put one balloon. Okay, the bottle is empty still, and now fill the bottle with water. If you fill the bottle, initially the balloon was not inflated, but after applying, the balloon becomes stretched, inflated balloon. The previous experiment we showed that the pressure exerts here at the down, and here we say that pressure exerts at the side of the walls also. So pressure exerts here, and due to that pressure goes this side and the balloon becomes inflated. So that says that a liquid exerts pressure on the walls of the container. Any container, any shape you take, you fill it with the water, any liquid, and you see if you cut it like this, you can see that the wall of the container is showing that the balloon is inflated because of the pressure on the walls of the container. Alright. Now next activity is activity 11.10. Everybody look at the activity. Take an empty plastic bottle or a cylindrical, just same bottle if you take, and what you need to do is you have to make holes at the same level of height on all the direction of the bottle. Like this bottle if you take, and you make hole this is also one part of the bottle. Here also you make hole, other side also you make hole, and the holes are at the same level, 3-4 holes as shown in the figure. Then you can see that when you fill water in it, water will come out from all the sides, showing that all the holes are having pressure, and that shows that liquid exerts equal pressure in all the directions in the same depth. So same depth, all the holes get same pressure. Okay. Now these 3 experiments you have to remember. The first experiment we just said that water, liquid exerts pressure. Second experiment is side of the walls of the container exerts, it is also given pressure by the water. So water exerts pressure on the side of the walls. And the third experiment, that liquid exerts pressure at the same depth in all directions. Understood? So 3 experiment, liquid exerts pressure is this, Second, liquid exerts pressure on the walls of the container. And third, liquid exerts pressure in all the direction of same length. Okay. Next is whether the gas exerts pressure or not. Liquids exert pressure whether the gas exerts pressure or not. You have seen that game, you must have played it. You feel the balloon and you close its mouth. You fill balloon with air, you close its mouth. If you open it, slowly the air comes out and the inflated balloon becomes small, small, small and completely plain. So here we can say that gases too exert pressure on the walls of their container. Now, atmospheric pressure. Children, this is very, very important. We are not aware of it. Do we have atmosphere around us? You have learned this in science, you have learned this in SS also. We have air around us. The air envelopes. We are in the oceans of air, right? There is everywhere air around us. And in this air exerts pressure, right? Now here atmospheric pressure is the pressure exerted by atmosphere. Now what is the proof that there is air pressure? If you take a rubber sucker, a sucker is a substance, object, it sucks all the air from the surface. Now if you take a sucker and put it on a plain surface, smooth surface, the sucker will stick or fix with the surface so tightly that it will be very difficult for you to remove it, to detach it. And this is, many times you must have experienced that you take the cover of the bottle and you put it in your mouth, you put it on your wrist and you press it, and all the air, suppose, is gone from it, it will be sticked. You have done this many times in the school. The cover of the pen, you press it here and you can see that the cover remains here even if you do like this. Why? Because you have taken all the air from the cover. Okay, when you press the sucker, the air between the cup and the surface escapes out and the sucker sticks on the surface. Now, do we have pressure around us? Yes, very much. There is so much pressure around us. You want to know the magnitude? The exact magnitude is 225 kg of pressure is around our body, around our head. 225 kg means one weight of one elephant. That much pressure is on our head. Then why not our head is crushed? Just because the tissues that we have, the body tissues has so many arteries and veins are here and they have liquid in it, and this exerts pressure outwards, body pressure, and this is atmospheric pressure inside. Suppose I call body pressure P1 and this is atmospheric pressure. P2. Then P1 is equal to P2. That is why we do not get crushed. Though we have so much of pressure, we do not get crushed because our pressure is equal in opposite direction. Okay, very important question. This is for your exam, but paper I am not going to set it, so I don't know. I cannot ask this question. I don't have that permission. Okay. Now, one scientist in 17th century made one excellent experiment. Otto von Guericke. He did one experiment. He took one big he invented one pump, and that pump used to take all the air from the vessel. So he demonstrated one dramatical experiment of air pressure. He joined two hollow metallic hemispheres together. See in the figure 11.20. He took one big hemisphere, two hemispheres, and he joined them, and then he sucked all the air through that pump. So there was vacuum inside, and then with that hemisphere he connected 8 horses on both the sides. So total 16 horses were trying to detach those two hemispheres, but they could not do it because of the atmospheric pressure. The atmospheric pressure on the hemisphere from from outward to inward was so much that they could not, these hemispheres which were joined together, the pressure here was so much this side that this pressure of the horse could not detach them, and because F1 of atmospheric pressure and F is horse pressure, so not F, we'll call it, okay, P and PH. P is atmospheric pressure and PH horse pressure. So PA was so great than P horse, and that is why the hemisphere could not be detached. That's all for today. My time is up, and exercise, some questions I have given you. Give to example each of situations which you push or pull to change the state of motion. Give two examples of situation in which applied force causing a change in the shape of the object. Third question, fill up, you can do. Fourth, you can do. Next I will try to do it with you, and next time after finishing we'll go to the next lesson, friction, 12th lesson. That's all for today. Thank you. Sir, Manisha, thank you so much, and complete your exercise. And that's all for today. Try to complete the question answers today itself.